So in the last video, I showed you a little bit about your field of vision, right? And about how if you did everything perfect, you would end up with something that looked a lot like this, which is, kind of screwy, right? And it was because you don't see everything at once. We're really back to the field of vision. You're only concentrating on this part. Okay, and that's one of the reasons why three-point perspective can look so screwy, right? But if you were to use three-point perspective right in your visual focus, it would look more or less okay. In fact, it might look pretty good. Okay, we also talked about how I got past the just good old straight horizon line and created actually a horizon sphere. And this horizon sphere we were able to flatten out into a circle. Okay, and it had special points, right? Here's sort of a diagram that will show that you've got your picture plane, that's where your drawing is. You'd have your field of vision, and you'd have your geometric vanishing points, right? And those are the vanishing points that you would get if something was at a right angle. In other words, if something was in more or less two-point perspective. Okay, and these are a very special place. We get these because if you were to take a hoop like this, kind of like this basketball here, right? So you've got this basketball, and you can see where you've got these lines going through it this way. And then if you turned it, let's say, so you can see, imagine if you would, the lines continuing themselves this way, then at this 45, if you were to draw a line straight down, let me get that all centered there, straight down, right, you would see that that right there, that point, right, that's where you get these. Okay, so that's a flattened out sort of drawing of what that would look like. Okay, so let's simplify that and just give ourselves this nice circle, right? We've got our vanishing points here for our two-point perspective, of course, one-point perspective. And if you had a third point, you'd put it over here because everything would go in ellipse down to that point, just like in this drawing here, where everything would ellipse down to that point. Okay, this looks similar, but really has nothing to do with it. Well, except that this is the field of vision, which would be somewhere in here. Okay, enough of that. That's my review for last time. So this time what we want to do is we want to take a look at tumbling blocks, making things go in all sorts of odd directions. Now before we do, we got to get a few things straight. Okay, so the first thing is this, is that a random rectangle is not a square. Those are two very different things, right? A random rectangle could be anything. A square is a measured structure. A random box is not a measured cube. Those are two very different things, right? So today we're going to work with just random boxes, okay? Because it's just going to make things a lot easier. In the next tutorial, we'll make cubes, and that's where it gets really, really crazy, tumbling and turning all kinds of cubes. Okay, but for now, we're just going to work with boxes. The other thing I had to make sure that we got clear was that this would be considered a right angle, something that is at 45 degrees, right, in comparison to an odd angle right here. And so you would even see that if I had a right angle here, it would run along the horizon line, and then even it would go down to these corners here. That'll be very important later. Okay, so let's see what we can do here. Tumbling and turning and spinning stuff around. So here we see that we've got a one-point perspective, and it's rotating in space, and here we've got the two-point perspective rotating in space. Now, just for, clarity, I'm going to go ahead and do a couple of these, although there's nothing magical about them, nothing that we haven't done before. We've got a central vanishing point here, and we've got our two vanishing points on the end over here. Simple one-point perspective. So we've got a square, here. Let's see if that's showing up good. I really want this to show up good, so I think I'm even going to switch to the big guns right here. Okay, so we've got this square right here. I have to correct myself right off the bat. That is not a square, it's a rectangle. If some of these end up looking like squares or cubes, that's just accidental and incidental. In other words, it wasn't on purpose and it doesn't really matter. Okay, so anyways, but we've got our vanishing point going off to the center. Nothing we have not done before, as you can see, vanishing point off here. Okay. And as we turn these in space using this central vanishing point, we could have, let's say like this one right here, and it would also connect not only to this central vanishing point, but also to one of the vanishing points on the side. Okay, just like so. Okay, so you can see how all of these boxes were turning and rotating in space as they moved away from you, but all still used the same vanishing point, the central vanishing point and a side vanishing point. And they all look very natural and work well together. The same thing can be said with 2-point vanishing points, right? So we've got this right here. So we'll go ahead and just make one of them, nothing that you haven't done before. So if I had this here, and I sent these off to the 2 vanishing points, so there we have our standard 2-point vanishing point box. And you'll see that they look just fine with the 1-point boxes that we made, or I should say the ones with the central vanishing point. And they'll also look just fine with each other with 2 more on the sides. So there we have it. We've got our simple 2-point vanishing point boxes, and we have our central vanishing point boxes that also come to the vanishing points on the sides, right? And they rotate in space and they turn in space just fine. Easy peasy. You didn't have to do anything special, anything new. That's kind of all old information, but we can see that they work well together, no problem. Now let's take a look at some odd angles here. So this is where it gets a little bit complicated. In one of my previous tutorials, I showed you how to make an odd angle, and I'm going to show you that again real quick just for review. Okay, so if I were to create a square, let's say, and we do have to make this with a square. So let's say right there. So here and here. And I know that this is going to be a square because this is just at a right angle to our 2 vanishing points. If I go across, making a line across horizontal, I'll know that is in fact a square. So just like so. Okay, continue to take this back to the vanishing points. And everything is lined up right and true. Okay, the thing is that to create an odd angle, we just have to rotate it within this square. We have to make a square within the square. So now, the method that I showed you before was to divide the square up evenly, and that would be easily done by going here, cutting through, right? And then you could go through the center, again, and just keep dividing it up. and you'd end up with a little grid, something I got all the points either from the edges or some of the points from the middle, just like so. So now that I've got all these squares, 1, 2, 3, 4 squares this way, 1, 2, 3, 4 squares the other way, you know, and I could keep subdividing those. Then I could just say like, well, okay, let's pick a point. So for instance, let's pick this point right here, and we know that every one that's over 1 is where we'll grab a point. So we'll point there, over 1, here's a point, over 1, here's a point. All right, and so if I were to connect those lines, I would get a box. Let me do that with a little bit darker pen so you can really see that now. So by connecting all the points, I got a square. Once again, a perfect square in an odd perspective. Okay, odd because it's not at a right angle and it's not straight on. Okay, and it could have been rotated anywhere, here or here or here, doesn't matter. Okay, so then if I wanted to make this into a box, remember we're making boxes, not cubes, what I could do is if I follow this line to the horizon line over here, I'll see that it makes a point on the horizon line. And that is one of my vanishing points. The other vanishing point is off of our chart altogether. It's somewhere off out here in the distance. Okay, so how would I make a box out of that? Well, it's not too hard. I would just do this. I would say like, well, how tall am I going to make this? I'll just create my leading edge like I would do any other time. And I would take this leading edge back to my vanishing point. So this angle was easy to get because it just goes back to the vanishing point. But how do I get these angles over here? Well, it's actually not that hard if you think about it, because we've got this square. The square is at a right angle down here, the original square that we drew. And so if I was to draw right here from the corner and go back to the original vanishing points here for the right angle, wherever this intersected would be right here. This would give me my height. You see, wherever this intersected here would be my height. Okay, well, if I've got that height here, then I can also send this side back here to the original vanishing point, to a right angle vanishing point. Okay, well, fair enough. If this one intersects here, then this one has to intersect here. Remember, because it's just all on this grid, so this has to intersect here. Just think about it, you'll get it. Okay. So that's how I know how tall this one is. From here it's easy, because all I have to do is connect this point here and this point here, and I've got this, and so now this just goes back to here, and then this and this, I just connect these two, because, you know, this just lining up here with that original point down here. And if I was to extend these lines out, they would come back to a vanishing point, I think actually somewhere right around here. Anyways, but it's not important. We didn't actually need it. We were able to figure it out because we used a right angle as our base for the original square, and then we made an odd angle by making the square into a grid, and we were able to find the points. Okay, kind of complicated, I know. I have got an easier method coming up real soon, but let's just see. does the odd angle also work well with our normal boxes? I'm going to go ahead and fill some of these in just a second. This one over here is an odd angled box. This box had been constructed just like this one. As you can see, I've got the grid down here, and actually this one's kind of cool because this one ended up having a vanishing point come over here, but this one actually did have a vanishing point that was on our paper right here. So that was kind of nice. Didn't even really have to calculate, but I would have calculated in the exact same way as I'd done this one here. Okay, so that works. And so now we'll see that this box also plays very well with the other boxes. So here it is with the other boxes filled in. We've got our classic 1-point perspective box. We've got a 2-point perspective box right here. And we've got a 1-point perspective that is turned at an angle away from you. Okay, and they all look very well together. They all natural. You could easily use all these different angles in a picture together. So this method is easy enough, really, and it's super accurate. But there is an even easier way to do it. Okay, so we're going to use a perspective sphere, and let's take a look at this for a second. Okay, so if I had a square, and it was at a right angle, just like so. And I was to draw an axis through the square, we would see that these axes line up with our points out here, with these corners, right? And these corners intersect this outer circle. Remember, I said this thing is kind of magical in the way that it works in its proportions. Okay. So anyways, if we were to follow this down and then up, we would get our 2 points of perspective on each side, right? And from there, of course, we could draw out our classic box. So there it is, our classic right angle box. And here are the vanishing points. And we got this by going from the axis, and we hit this corner that is right on the outer part of the sphere, drawing up to our horizon line. Well, if you could do that at a right angle, couldn't you do that at an odd angle? Let's see. So there's my square at an odd angle. Now I'm going to draw an axis through it. So there's my square, and there's my axis. Of course, you wouldn't have to draw a square. You could just draw an axis at a right angle, and that'd be just fine. So let's see what happens. I'm going to go ahead and turn this over this way to give us a new area to work with here. Okay, so I'm going to take this axis, and I'm going to line it up, and we can see that if we go up this way here, bring this on down so you can see it, and you see we just run it up, run it up, run it up. There it is. So we make a point right along this outer circle, right? And if we were to come straight down, we would get a point right about here. That's one of our vanishing points. On the other hand, if we went to the axis going this way, we could run it out, once again, all the way out to this outer circle, drop it straight down, and we'd get a point here. Okay. Now, let's see if we can make a believable box using those. So you see, we get a very believable box turned at an odd angle this way. Now, does this account for things when they're turned really extremely, almost frontal to us? No, it doesn't. No system is perfect. If you had something like that, maybe you'd go ahead and use the grid system like this. But for most of what you might need to do, this will work out fine, and it's a lot easier. All right, so far everything that we've done in all the lessons has been more or less along this horizontal horizon line here. But we can also tumble the boxes very easily, basically just by turning things like this along this circle. Let me show you what I mean. So here I have various boxes turned at different angles, tumbled, so to speak. Let me make a couple of them, and you can see how easy it is. We'll start with our classic right angle box along the horizon line. Okay, so there's my classic box, sitting nice and horizontal the way that we're used to it. But let's go ahead and make a box that's now a little bit more tumbled. So what I would do is my paper here, I've got it right here. All I have to do is spin it. Thus creating a new horizon line. And I can just use my same vanishing points if I was to make another right-angled box. Let's see what happens. Okay, so you can see that this is just lining up with the vanishing points just like before, but when I turn it back around, the effect is that I've got a box that's totally tumbled. Let's try that with a few more examples. So for instance, if I wanted to have this guy right here, what I could do is just line it up here using this quadrant, right? And have my vanishing points here. So this is our classic central vanishing point box, but put at an angle this way. Very simple. Okay, and so you can see that we've got this one to our central vanishing point. And then instead of taking it out here, I've actually taken it, well, actually a bit further, because I've taken it to what would be our third point vanishing point sort of sphere of influence here, right? But that's okay, that worked fine for me. And the important thing, and this is going to come up later when I talk a little bit more about three-point perspective, is that it's got to be at a right angle. So notice this, that if we have this right here running along this axis, this way, right, then these parts that would normally be, our vertical part of the box would have to be also at a right angle to it. So in other words, we've got this here, and this is at a right angle here. It's got to be, okay. Otherwise, this is going to be all skewed. Okay. So let's take a look at one more example here. We've got this here, and I can go from this point to this point. Once again, this will have to be at a right angle to these. All right, and so that worked out well. And you can see, here it is. I've used this vanishing point and this vanishing point here. Once again, at a right angle. And all these boxes work very well together. They're just all tumbling in all different crazy sort of ways. Let's do a couple more examples. Okay, so in these examples, they're going to be kind of the same, but kind of different. But they all run along the same principle here. Okay, so if I've got my two vanishing points right here, if I just turn them along the wheel, I could get different vanishing points, okay, like different horizons. So for instance, if I was to take this here and spin it just a bit, okay, I've got this and this as my vanishing points. I can just take this out, and we have basically the classic two-point perspective, but along the horizon line. And that works just fine. Notice, once again, right angle, okay? Okay, and you can see that this looks just right, no problem, right? And as we turn it back, we can see looks very natural. Now, before I'd taken a central vanishing point here and a central vanishing point at one of the other quads right here. But it would work just as well to bring it over here. It'd just be a sharper angle. So let's try that. So if I've got this right here as a vanishing point and this right here as my next vanishing point, let's see what happens. Okay, you can see that that one looks just fine. And you could also see probably that it would live very well along one of these other ones where we had drawn the vanishing point out further away. But, no problem. Okay, so tumbling blocks is kind of extreme, right? So this might be a good opportunity to use three-point perspective. Let's see what that looks like. So you can see I've just done a classic two-point perspective box, but this time sending it down to the vanishing point down here to create a third point perspective right here. And it just makes it a little bit more extreme and a little bit cooler as it goes tumbling through space. Good time for using that 3-point perspective. Now, I keep saying to put things at a right angle, right? Let me just show you what it might look like if you didn't put things at a right angle, because it's going to look just totally crazy and wrong. Okay, so I've set up my box. I'm going to have my vanishing points here, and I'll have my vanishing points here. Makes sense, right? Well, let's see what happens. As you can see, our box looks just kind of skewed and wrong, because we just can't do it like that. We have to have these 3 points in alignment. In other words, you have to have this point here at a right angle to these. This time, I'm going to get all my 3 points in alignment. So let's see what happens. I wanted to just preserve these guys right here to make this box sort of in the same space. And in doing so, what I've done is I've shifted this third vanishing point down to here, moved it over so that it would be in alignment. You could do that. It's just yet another crazy way that you could tumble things. Let's see what happens. This box now being in alignment looks a lot more, well, right. And as you can see, once again, even tumbling them all crazy, everything can live together very well. Okay, so now let me give you just a couple last examples to wrap things up. A few things that we haven't done yet. The first thing that I'll do is a classic 1-point perspective coming out of the central vanishing point. This one's easy. We don't have to do anything special. Okay, so it looks just normal and fine. The only thing to consider is that once again it is at a right angle to the axis. Let's do another example of it coming out of the central vanishing point, but this time let's put it at an angle. So I'm going to spin it like this, just to tumble it a bit. And this time I'm going to line up not only with my central vanishing point, but also these vanishing points here to give a 3 vanishing point effect. Okay, so in this example, I've taken the leading edge and I've aligned it with our central vanishing point. Okay, and that's creating 1 point. Then at a right angle, I've got this point here and this point here. So we're disappearing back that way. And it looks very right and very natural. Now, this is assuming that if we were to continue to tumble this block, it would be straightforward over here. In other words, the leading edge would go back here and here, right? But you could do the same thing. You could bring it all the way over here, assuming that the turning point was over here, this way. Okay, so let's do one last example. This one using an odd angle. All right, so here I've drawn an axis. And remember, I don't have to draw a square, just an axis at a right angle. I'll follow this out to my outer circle and see where it goes. Okay, so I follow this out and I get a point right over here, right? And I follow this axis here and I get a point out here. Now, I'm going to drop that down to my horizon line and I get this point right here, just following this down. And then if I drop this down, I'll get a point right here, just following it down to my horizon line. Okay, so then I can line this up, okay, with this right here, and we'll be all set. Okay, and it looks pretty good. We've got our 1 vanishing point over here that we derived from this angle. We've got our 1 vanishing point over here that we've derived from this angle, right? And then we've got this one here, which has to be at a right angle to this here, so it's dropped down right here. Okay, so we see we've got all kinds of things tumbling and turning and moving in space. And that's how we could handle that. Now, the only thing is that these were all boxes. These weren't measured cubes. So in another tutorial, I'd like to show you how to work things out with a measured cube. Now that's where things get really weird.